Okay, so today we're going to learn three more theorems, and I thought I would do it by making a video or two. So in this one, this theorem that we're about to learn only works with right triangles. And actually all three theorems that we're going to learn today are dealing with the same situation. And a lot of the problems that you'll have today you'll also find in the Jesuit packet. So I think that this will be also a good help with that. So in this case we have a right triangle where an altitude is drawn from the right angle of the right triangle to the hypotenuse. So here's my right triangle. It's kind of turned on its side. And the altitude, if you remember from the previous chapter, an altitude is just a line that leaves the vertex that has the right angle and makes a 90-degree angle with the other side. So when this happens, it's divided into three different triangles. So the big one is easy to see, and we'll just deal with that one first. That's ABC. And this actually gets quite complex. So if you want to start jotting these down in your notes, it's probably a good idea. So we have the big triangle ABC, and then we're also divided into two smaller triangles. This one on the right, and then this one on the left. So in this situation, where an altitude is drawn from the right angle to the hypotenuse of a right triangle, it's divided into three triangles that are all similar to one another. So the big one is triangle ABC. So go ahead and spot that with your eyes. ABC, it's the big one. And C is my right angle. So here's C, triangle ABC. And it is similar to, I'm not sure how much we've talked about this, but that's the similar sign in math. It's just the top part of the congruent symbol, and that just means same shape. So it doesn't have the equal sign under it, which would be congruent, which is same size and shape. This is just same shape. So ABC is similar to triangle CBD. So CBD. And again, you can see D is my right angle. And I know that that matches up with C and ABC, which was the right triangle. And then the last triangle that I need to name is this one on the left. And it is similar to triangle. And to name this one properly, we would have to name it A, C, D. Again, ending with the right triangle, or the right angle. And then you want to be able to spot corresponding sides of all of these three triangles. So if I'm looking at the big one, of the whole big triangle, the hypotenuse is AB, as I can see right here. And then that must mean that the hypotenuse of the triangle on the right is CB, because it's in the first two position there. And then of ACD, the hypotenuse must be AC of this left triangle, which it is. So you want to start spotting angles and sides that correspond between the two, because we're going to be setting up proportions with these, just like we did with yesterday's theorems. And in yesterday's theorems, if you remember, it was just something divided up like this. It didn't have to be a right triangle, but it was divided into three triangles that were similar to each other, the top one, the second one, and the third one, and we lined up corresponding sides. You're going to be doing the same thing today with this first theorem by lining up corresponding sides of these three triangles that are formed when you have a right triangle and you draw an altitude to the hypotenuse. Stay tuned for the next two theorems.